Good morning. My name is Sanika Patil. We are from ADCET IoT branch. Firstly, I would like to thank you for giving this golden opportunity to present our ISC topic regarding block coding. This topic we are presenting under the guidance of Prachi ma'am. My group members are Asmita Bhandare, Vaibhavi Kumar, Shraddha Kadam. Block code is used to convert the software code or an algorithm into any particular form so that errors, if any, in code can be minimized. Block code can be also applied in domains of telecommunications, information theory, and coding theory. The main idea is to encode a message for a recipient in a such a way that the recipient is able to address errors, if any, in the message with the help of the encoding. Block coding is applied before of the line coding. The next one is the basic principles of block coding. In block coding, a fixed number of data are taken together and encoded in a larger blocks of bits. This encoded block is transmitted over the channel at the receiving end. The original data is reconstructed from these blocks. Blocks are designed to detect and correct the errors that may occur during the transmission. They add redundancy to the data in a such a way that errors can be detected and, in many cases, corrected. As we see in a diagram, the bits of information are converted encoded bits by using block code, which is also known as the encoding operation. Thank you. The further part will be continued by Asmita Bhandare.
Hello, I will explain the benefits of block code. First, error detection and correction. One of the primary benefits of block coding is its ability to detect and correct errors that occur during data transmission. By adding redundancy to the data, block codes enable receivers to identify errors and in many cases recover the original data without needing retransmission. Second, improve reliability. With error detection and correction capabilities, block coding significantly improves the reliability of data transmission over noisy channels. This is crucial in various communication systems where the data integrity is paramount, such as telecommunications, networking, and storage system. Third one is the versatility. Block coding techniques are versatile and can be applied to various types of data and communication systems, including wired and wireless communication, storage systems, satellite communication, and digital broadcasting. Different block codes can be tolerated to specific application requirements. Fourth, standardization and interoperability. Many block coding schemes are standardized by organizations such as IEEE, ITUT, and ISO. Standardization ensures interoperability between different systems and devices, allowing them to communicate effectively using common error correction techniques. The last one is real-time processing. In many applications such as real-time communication systems or streaming services, error detection and correction must be performed quickly to maintain the flow of data. Block coding algorithms can be implemented efficiently for real-time processing, ensuring timely error correction. The next point is the types of block coding. First, error detecting codes. Error detecting codes are designed to detect the presence of errors in transmitted data. They add redundancy to the data in such a way that errors can be detected but not corrected. Common examples include parity codes and checksums. Error correcting codes. First, error correcting codes are designed to not only detect errors but also correct them to some extent. They add redundancy to the data in a structured manner, allowing the receiver to reconstruct the original data even if errors occur during transmission. Examples of error correcting codes include Hamming code, Reed-Solomon code, BCH, that is Bose-Chaudhary-Hackvenjem, turbo codes, and LDPC, that is low density parity checks codes. Thank you. Next part will be continued by Vaibhavi Kumar.
I am going to explain the working of block code. First is encoding. Encoding means the process of converting a sequence of characters like letters, numbers, punctuations, and symbols into a format for storage or transmission. Next one is error detection. When the encoded block is transmitted over a noisy channels, error may occur, causing some bits to be flipped. At the receiving end, the receiver block is decoded using the same algorithm used for encoding. Error correction. If the block code used is capable of error correction, the receiver can attempt to correct detected errors. This is typically done by analyzing the pattern of error and determining the most likely original code words. Next is decoding. Decoding means the process of translating written words into speech, usually by matching letters or letter combination to their sounds. Last one is a feedback and retransmission. In some cases, when errors cannot be corrected, the receiver may request retransmission of the erroneous block from the transmitter. Here, as we know, shown in the figure, division of stream into m bits group, we can see that there are number of bits which are represented by m bits which are getting converted in substitution state m bits to n bits. In block coding, which convert to m bits to number of n bits and combining n bits group into a stream. Thank you. Next part will be continued by Shraddha Kadam.
Advantages of block code. First one is flexibility. Block code can be used in various applications and can adapt to different scenarios. Second one is scalability. Block codes can be easily scaled up or down to accommodate different data transmission rates. Third one is redundancy utilization, which helps in error detection and correction. Fourth one is security. Block code can enhance the security of transmitted data by adding encryption. Fifth one is error detection and correction. Block code can be detect and correct errors that occur during data transmission. Last one is standardization. Block code follows standardized algorithms and protocol. Next point is disadvantages of block code. First one is increase the bandwidth overhead. Block codes add extra bits to the transmitted data, which increases the bandwidth required for transmission. Next one is complexity. Implementing and decoding block code can be complex, requires special knowledge and algorithms. Third one is limited error correction capability. While block code can detect and correct errors, they have limitation in handling multiple or several errors. Last one is latency. The process of encoding and decoding blocks can introduce some delay and latency in data transmission. Next point is applications of block code. First one is digital communication system. Block coding is used in wired and wireless network like Wi-Fi and cellular network. It helps ensure that the data being transmitted is accurate and reliable. Second one is satellite communication. When signals travel long distance in satellite communication, they can face challenges like signal degradation. Block coding helps to overcome this issue. That is also used in digital broadcasting. It's helped to improve quality of reception and especially in areas with weak signal strength. Fourth one is IoT. In a world of IoT where devices are interconnected and communicated with each other's, block coding is used to ensure reliable communication and maintain data integrity. Last one is military and aerospace system. Block coding is also employed in military and aerospace communication system. Block coding helps to protect sensitive information and ensure that communication remain intact even in challenging situations.
Now, the time of the conclude this topic. In conclusion, the block coding is a fundamental technique employed across various fields to ensure reliable data transmission and integrity in presence of noise, interference and other channel impairment. Through the addition of redundant bits and sophisticated encoding and decoding algorithms, block coding enables error detection and correction, enhancing the robustness and quality of communication system, data storage technologies and digital services. Here I am thankful for your attention. Thank you.